Hello learners, let me ask you something honestly. When you see a function question, do you understand it or just try to survive it? Domain, range and transformations, they are not confusing because they are hard. They are confusing because no one showed you how they actually think. In this video, I will strip functions down to their core, and once you see it, you will wonder why this ever felt difficult. So without wasting much time, let's start the class. We will do revision of functions, domain and range, and also transformations in this video. I will be teaching you concept through the question. So we'll be moving through the past paper questions and then I will be covering all the concepts. All right. So let's start with the first question. Functions fg are defined as follows, where m and n are constants. Solve the equation fx equals to 0, giving your solutions in the form of x a b root c, where a, b and c are integers. All right. So what we can do over here is, we know fx is x minus 4 root x plus 1. We have to equate it equals to 0. So we will equate it equals to 0. Sir, we have been taught how to solve a quadratic equation, but we don't know how to solve this root equation. Very simple. Let us convert it into the something which we know. Whenever you get stuck in some questions of quadratic, convert it into a familiar equation which you can solve or put into your calculator as well. So what we will do over here is, we will assume this root x equals to y. All right. You can put it equals to u as well, whichever you feel comfortable to you. Now, what is x? X is root x times root x. Agreed or disagreed? Yes, sir. So can I write instead of x, y times y, that would be y square minus 4y plus 1 equals to 0. Now you can use quadratic formula. Quadratic formula is very important. You have to write it down. If you are using your calculator also, just write it down, okay? Negative 4 plus minus square root negative 4 square minus 4 times 1 times 1. Okay? Whole upon twice of it, that is twice of 1. What is quadratic formula, sir? Quadratic formula is x equals to minus b plus minus square root b square minus 4ac upon 2a. Sir, what is this ABC? Let me teach you. Every quadratic equation can be written in this form: ax square plus bx plus c. The coefficient of x square is a, over here a is 1. The coefficient of x is b, over here b is negative 4. And the constant term is c, over here is 1. I plugged in the values over here. Now you can use your calculator. Just write the quadratic formula, then you can use your calculator. So we will get y equals to 2 plus root 3, or y equals to 2 minus root 3. Okay? We know that root x equals to 2 plus root 3, or root x equals to 2 minus root 3. Plug it in your calculator, just square both sides. So x equals to 2 plus root 3 whole square, or x equals to 2 minus root 3 whole square. We will get 7 plus 4 root 3 for this one. Yes, you can put your values in your in decimals as well. Okay, you can answer in decimals. So it would be 7 plus 4 root 3, and this one would be 7 minus 4 root 3. Very good, learners. Let us move on to the next one now. All right. So it is given that fx is equivalent. Okay, is equivalent. We can call it equivalent. Okay, for all values to g composite function of hx. All right. Find the values of mn. So first, let's calculate this one, because fx we know. So we will calculate g hx. That would be, what was g? G was this one, mx square plus n. We will put this instead of this. Okay. Instead of x, we will put root x minus 2. That is what we mean by g. hx. Do you agree with me or not? Yes, sir, we agree 100%. So let's put it. So it would be m x to the power half minus 2 square plus n. Square it. You will get a minus b whole square is a square minus 2ab plus b square. I'm expanding the brackets, which would give me x minus 4x to the power half plus 4 plus n. Okay, multiply m by all of the terms. You will get mx minus 4mx to the power half plus 4m plus n. This is simple algebra what we are doing here. If you have doubt in these steps as well, please work on the basics first. I will upload a basic video as well. Just comment basic. I will upload. Now we will compare this. We will compare this. Can we add or subtract anything? No, we cannot. So we will compare this with fx. So it would be mx minus 4m x to the power half plus 4m plus n is equivalent to x minus 4x to the power half plus 1. See, the constant term equals to 1. Agreed? So I will write it down here. 4m plus n equals to 1. Okay. The coefficient of x to the power half is negative 4. So 4m equals to minus 4m equals to negative 4, m equals to 1. We got m equals to 1, we will plug it in over here. So 4 times 1 plus n equals to 1, n equals to negative 3. You got this one also correct, learners. Clap for yourself and let us move on to the next question now. Don't forget to subscribe to the channel and like this video if you enjoy. It motivates me to keep posting more videos like this. Alright, got that one? Let us try to solve this question now. Okay, a function follows is defined as follows, and for x is greater than equals to 2. We have to find an expression for f inverse of x. Okay, so now let us try to solve this question. How can we solve this question, sir? Let me explain you step by step. We will go. So we have to find f inverse x. So we will write y equals to x square minus 4 x square plus 4. Let's make x the subject. Can we make x the subject? Yes, sir, we can make x the subject. How? Let me teach you. Just bring x over here. So it would be y x square plus 4 equals to x square minus 4. Multiply y inside, it would be y x square, okay, plus 4y equals to x square minus 4. Now we have to make x the subject, right? So keep the x term to one side. These are the terms with x, see? These two. Keep it on one side and rest to the other. So I will send 4 over here. It would become 4y plus 4 equals to x square minus yx square. Now tell me, can I take x square as common? Can I take these two as common? Yes, sir, you can. So 4y plus 4 equals to x square, 1 minus y. So which would give me 4y plus 4 upon 1 minus y, that equals to x square. I have to make x the subject, not x square. So I will take square root on both sides, which would give me 4y plus 4 upon 1 minus y equals to x. You can take 4 common from here. So it would be y plus 1 upon 1 minus y. This is on square root. Can we take 4 out of the square root? Yes, sir, we can take. It will become 2. So 2 twice 1 plus y upon 1 minus y equals to x. So what is the inverse? Inverse would be y equals to 1 plus x upon 1 minus y. This should be your final answer. Don't leave it over here. This should be your final answer. Show me a double thumbs up in the comment section if you got this one also. Okay. What I did was I just made x the subject. This is what you do in inverse. All right. Let us move on to the next question now. All right, so we have this. Show that 1 minus this can be expressed as this, hence state the range of the function f. 4 mark question. Very easy for you. We will do it together. Okay. So we have this. So we have 1 minus 8 upon x square plus 4. Let's take LCM. Multiply the denominator also by x square plus 4. So we have to multiply the numerator as well. So it will become x square plus 4 upon x square plus 4 minus 8 upon x square plus 4. Okay. Now the denominators are same. So we will have x square plus 4 minus 8. We will write the denominator one time. Don't add the denominators, all right? X square plus 4, that would be x square minus 4 upon x square plus 4. That's what we have to prove, and we have proven it. Okay, hence proved. You can write QED after this. All right, now let's talk about domain and range of this function. All right, so the next part stated that we have to find the range of this function. So the function was fx equals to 1 minus 8 upon x square plus 4. Now let's try to understand the concept of range. Range is the output. What is the maximum and the minimum output which this function can give within a limited domain? So the domain of this function was given to us in the question, that was x is greater than 2. So domain was x is greater than 2. All right, this is done. Now listen very carefully. To find the range, I will put this 2 into this function first. So it would be fx equals to 1 minus 8 upon 2 square plus 4, which would give us 0. So we know that the range is greater than 0. Why not less than 0? Because if I put 3 over here, it would become value greater than 2. It would become fx 1 minus 8 upon 3 square plus 4. This value will become smaller. Yes or no? It will become smaller. It would be lesser than 1. So fx equals to 1 minus 8 upon 3 square 9. 9 plus 4 is 13. 8 by 13. See, for 2 you are having answer as 0. Okay. When as the value of x is increasing, we will have greater answers. Yes or no? So x is greater, the range is greater than 0. You can put 4 over here. You can put 5 over here. You can put 10 over here. You can put 20 over here. And see, as we are increasing the value of x, the value is also increasing. As the value of x reaches infinity, as it reaches infinity. So instead of x, if I put infinity, as it reaches infinity, tell me 1 minus 8 upon infinity plus 4. This value will all equals to 0 or not? As it approaches to infinity, I'm saying. Yes or no? As x approaches to infinity, because it is given to us that x is greater than 2. That means it could be infinity as well, infinite. So as x approaches infinity, this value will become 0 and the output will become 1. So it would be between 0 and 1. Value would be 0 and between 0 and 1. This is the range. This is the range. Sir, why does the value become infinity? Okay, let's talk about it. Why does the value become infinity and why does the answer become 0? Okay, now tell me one thing. Let us talk about this. If I put 1 upon 100, what is the answer? 0.1 and 2, 0.01. If I just keep on increasing this number, this is not even close to infinity. This is not even close to infinity, my friends. Will the answer become like this? Somewhat 1. Yes or no? If I increase the 0, more zeros will be placed over here. You can see as I'm increasing the denominator and as it is proceeding towards infinity, we do not know the end of infinity, right? So as it is approaching to infinity, the value its complete value of 1 upon infinity is approaching towards 0. So I can put this value as 0 and 1 minus 0 would give us 1. That's why I've written the range between 0 and 1. Alright. See, it will get close to 0. Why am I not including 1? Because it will get closer to 1. Something will be subtracted, right? 0.00 infinite times 1 will be subtracted from 1. It will not reach 1, but it will tends to reach 1, right? Because 1 minus 0.0 infinite times and then 1, it will not completely reach 0, just less than it. Okay, that's why our range would be between 0 and 1. You got it or not, learners? If not, let us proceed to the next question and let's try to understand by this one. Okay, now they are asking, explain. This is the most common question in which learners do mistake, and it is for 1 mark only. But you do mistake in this question. Okay, but after this video, you won't. All right. Explain why composite function ff cannot be formed. Okay, ff cannot be formed. Ff cannot be formed. Listen very carefully. For any function to form a composite function, for any function to form a composite function, for example, I say fgx. So the complete range of this function, complete range, okay, should be in the domain of f, should be in the domain. What do I mean by this? Let me tell you. Let's say a function is fx and the domain of this function is the input values is x is greater than 2. Now we have gx. The range of this function is between 0 to 1. Yes or no? Now think of it. If I place this function inside f, the domain of fx was x is greater than equals to 2. And the range of gx was between 0 and 1. Is the complete range of gx inside the domain? No, see, it is greater than 2. And the range was between 0 and 1. So the complete range is not complete, not even a single value outside. The complete range is not inside the domain. Hence, this function won't be formed. So same reason we will write over here as well, because see, for ff to be formed, the whole range of f, क्या थी हमारी f की range? What was the range of f? It was 0 to 1, must be within the domain of f x greater than 2. As it is not, the function cannot be formed. All right, let us move on to the next question now, learners. This one. Now we will do some inverse question. After this, we will jump on to transformation. I hope till now the concepts are cleared. I know you need detailed videos. If you need detailed videos for these topics, do let me know in the comment section. I will make a detailed video as well. All right. Function f and g are defined as follows. These are the functions. The diagram shows the part of the graph y equals to fx. State the domain of f inverse. All right. Now listen. We all know that domain of f inverse is the range of f. When we do inverse, when we take out a function inverse, for example, f has a domain, let it be x, and range, let it be y. When we do inverse of f, the domain becomes, see the flips, these two flips, okay? Domain become y and range becomes x. All right, so whenever we do an inverse, the range and domain flips. Got this one? Domain of f inverse equals to range of f. Okay. Now, where is the function f? 2x plus 1. Okay. And 2x minus 1. This is a diagram of it. All right. See, now look carefully and think with me. Okay. Can you see this line? This function is not touching this line, it is going parallel to it. Can you see the line of the function? This was the line of the function. Yes or no? So this line is not included. What is this line? Y equals to 1. Yes or no? Think with me. Are you thinking with me or not? Yes, sir, I'm thinking with you. Very good. Now tell me. First, I'm talking only about f. I have to calculate range of f. F can take any values, but not y equals to 1. Y is not equals to 1, right? So this is the range of f. That fx can take any real values. See any real values it can take. Okay, but it cannot take only one value, that is y equals to 1. So the range would be y is not equals to 1 and it belongs to a real number. This would be same as domain of f inverse. So we will write for domain we use x, we don't use fx for domain. So what would be domain of f inverse? What the question was asking, it would be x belongs to the real number. We are not using fx, we use this for range. Okay, we use x for domain. This is the input, x is the input and fx is the output. We call fx as y as well. Okay, x belongs to real number and x is not equals to 1. See, not equals to 1. We got this one. Find an expression for f inverse x. All right, we have already done an inverse question, I will do it again for you. 2x plus 1 upon 2x minus 1 equals to y. Send this to the other side. It would be y times 2x minus 1 equals to 2x plus 1. Very good. Now multiply this. So it would be 2xy minus y equals to 2x plus 1. All right. Take x terms to the one side because we have to make x the subject to find inverse. These two are x terms. Take one to the other side. Side changes, sign changes. Actually, we are not changing signs, we are just balancing the equations. Okay, to make the concept clear to you, I'm just using these terminologies. Okay, so it would be minus y minus 1 equals to 2x minus 2xy. I took these term to the one side and this term to the other. I can take x common from here. I was thinking the same, so that I can take x common and I can make it the subject. So it would be 2 minus 2y. Put it in division and you will get your answer as minus y minus 1 upon 2 minus 2y equals to x. This is your inverse. So we will write it like this: minus x minus 1 upon 2 minus 2x equals to y, or f inverse of x. You can write it like this. Okay? This is your inverse. Very good, learners. You got this one also correct. Let us move on to the next question now. So the next question says, find G f inverse 3. Okay. So what was G? G was x square plus 4. So we had Gx as, now we will plug in G f inverse 3. Okay. So what would that be? First find the value of this one and plug it into G. So I will put 3 over here, which would give me which would give me minus 3 minus 1 upon 2 minus 2 into 3. This is minus 4, and this one will give us 2 minus 6, that would be again minus 4. This is 1. So the value of this function is 1. I will put it in gx. I will put instead of x1. So it would be 1 square plus 4. That would give us 5 as the answer. Very good, learners. Very good. I found the value of this one. Find the value of this one. I have replaced x by 3. See? 3. See? 3. See? 3. Very good. We got the answer 1. I plugged in 1 instead of x and I got the answer 5. Let us move on to the next question, learners. Now let us try some transformation questions. Y equals to fx and it has been transformed to the graph of y equals to 1 plus f half x. Before doing this question, you should know two things. If I have a function like this, fx equals to xy plus 2, okay? This is 2. If I have a function like this, and if it has moved horizontally to this point, like this was a horizontal movement, and you can see it has moved 2 coordinates. Yes? So how do I name this translation? Like this, 2. I have to write over here the horizontal movement. Now, if this function also moved vertically and it has reached over here, okay, so it has moved 1 to the upper hand. In vertically it has moved 1 up, so I will write like this. So what is the total transformation of blue to green? It is 2 1. Now how do I represent this translation into here, into this function? I can write it like this: fx equals to, okay, x square plus x plus 2. After translation it will become, this would become, listen very carefully. Now, instead of x, as you can see, it has been horizontally moved to right. Yes or no? In horizontal movement, we do the opposite. If it is 2 written over here, I will write negative 2. Repeat after me in horizontal. In horizontal translation, I do the opposite. If it is positive, I will write negative. This is the common error which most of the students do. Plus, instead of x, I will write x minus 2. All right? Plus 2. Now see. Now see the vertical thing. I moved vertically upwards. In vertical, it remains same because it was added 1. So I will add 1 over here. Okay, to the complete function, I am adding 1. If I add whatever change is done in y, we do to the complete function. So we are adding 1 to the complete function. So the resultant would be x minus 2 whole square plus x minus 2 plus 3. This is the first thing which you should know. The second thing which you should know is, let me draw it first. If my function was like this, okay? If my function was like this is 1 and this one is also 1. Now it has been stressed and it became like this. This point came over here. This one is 2 and this one is 2. All right? This is 2 and this is 2. See, it was a horizontal stretch by a scale factor of 2. So how can I show this transformation in this one? Horizontally, I have told you that we do the opposite. Repeat after me, opposite. 3 times repeat after me, opposite. If I'm multiplying over here, if I'm making it twice, in function I will divide by 2. Horizontally, it would become x by 2. That would be x by 2 whole square plus x by 2 plus 2. But why are we doing this, sir? Why are we doing this? Why are we doing the opposite? Because beta, if you can see, the value, the output is not changing. The output is same. The output is same. We are just stretching it. The output is same. We are changing the value of x, but the output remains the same. If you want to understand in depth, I will explain in depth in the next video. But just for now, understand that we do the opposite in horizontal direction. Okay, in horizontal transformation, not in vertical. All right. Now let's name the transformation, two single transformation. So first one is stretch. As you can see, we have stretch. So I will write stretch. What is the scale factor? I will write the scale factor. Scale factor 2 parallel to C. We were stretching like this. Horizontal stretch is parallel to x-axis. Is it or not? Tell me that. So parallel to x-axis. Got this one. And the second thing is we are adding one. So I will write translation. We are adding one to the function. Anything done to the function is done vertically, right? So translation by nothing has been done horizontally, so it would be 0, 1. These are the two translation which would give you 4 marks. Easy. Let us try this question now, learners. All right. So in the each of the parts A, B, and C, the graph shown in with the solid line has an equation y equals to fx. The graph shown with the broken line is the transformation. So this is the function and this is the transformation. All right. State in terms of f the equation of the graph shown with broken lines. So this was the function before. This is the function afterwards. As you can see in the y-axis, this has been reflected. The values of x has changed. If it was 1, it has now become negative 1. So simply, fx has been transformed to f minus x. Yes or no? Just tell me that. Just tell me that. If it was x value was 1, now it is negative 1. If it was 2 over here, it has become negative 2. So simply x has been become as x has transformed to negative x. Let's look at this question now. State in terms of f the equation of the graph shown with broken lines. So this was our original graph. This is the broken graph. What is the pattern that we can notice? We can notice that it has been stretched. It has been stretched. And see, it is a vertical stretch, not a horizontal stretch. Yes or no? Now, listen very carefully. This, whenever it is a vertical stretch, look for y. Look for fx, that is y. Okay? This coordinate was 1. This one, let me label it with blue one now. Okay? It was 1. Now it is 2. Okay. Now, next color. This coordinate was 2. Now it is 4. Very good. Very good. Now for the last one. This coordinate was 3. Now it is 6. Can you notice a pattern? Can you notice a pattern? See the blue line multiplied by 2, sir. See the green line multiplied by 2, sir. See the black line multiplied by 2, sir. So we know, and all of us know, and all among us know that the function is now twice fx. Yes or no? It has been stretched by the scale factor of 2. By the scale factor 2. Has it or not? Very good. And it was a vertical stretch. So x coordinate remains the same. Y changes. Okay? In the horizontal stretch, x coordinate changes, and in the vertical stretch, y coordinates changes. Whenever you do y, it means rise. We can descend or we can ascend. Okay? In x, we are talking about the horizontal movement. So we call it run. And this is rise. Are you now ready to rise with me, learners? All right. Let us move on to the next question now. All right, learners, let's try to solve this question now. The diagram shows the graph y equals to fx, which consists of two straight lines. The lines a dash b dash form the graph y equals to gx, which is the result of applying a sequence of two transformation in order to y equals to fx. State fully the two transformations. As we can clearly see, listen, to know about the transformation, pick any point. I'm picking this point. It has moved by -2. It has been translated by -2, right? In the vertical direction. All right. Now you will say, sir, it has also moved into the horizontal direction. Yes or no? So yes, I will write it down. Let me write it down. It would be 2 -2. This is the translation of B. Can you see the translation of A? It is again -2 and +1. Can you see the translation of C? The translation of C is +4 and -2. If all of these translation would be common, for example, if all these translations would be common, it would be like this: 2 -2, 2 -2, 2 -2. Then I would have directly written that there was one translation that was 2 -2. But it is not the case over here. See, horizontally, all the translations are different. Yes or no? Vertically, it is the same. That means that there is a horizontal stretch that has taken place. Okay, this is how you find where the stretch has taken place or not, whether the function has been stretched or not. And now we know that the function has been stretched, and now you know the direction as well. The direction is horizontal. So over here, I will write, are you thinking with me, learners, or not? So I will write, there is a translation. Okay, translation is -2 vertically but 0 horizontally. If it is 0 horizontally, then how can you justify this movement, and this movement? Yes, we can justify it. Wait and watch. See, after -2, the coordinate of A should be 1, but A dash is 2. Now you have to look for a pattern. The coordinate of B, the x coordinate, should be 2, but now it is 4. See, the coordinate of C should be again 4, but now it is 8. Can you see 1 has become 2 by multiplying by 2? 2 became 4 by multiplying by 2. And 4 became 8 by multiplying by 2. So it is clear that there is a stretch by scale factor 2. Okay, and what is the direction? Because it is horizontal stretch. Horizontal stretch is parallel to x-axis. So I will write parallel to x-axis. I hope you understood this concept, learners. Comment in the comment section that which topic you want me to explain next. See you in the next video.